Hello, everyone. My name is Amant. I'm co-founder of Mosaic AI.
Hi, everyone. I'm Jasbir. I'm also co-founder at Mosaic AI. And we both are open source contributor into popular frameworks like Spring Cloud, Netflix Orchestration Conductor, and of course, we have founded Eclipse Elmos, for which we are going to talk about, which we started in 2023 when this all was beginning, right, at the start. So we'll go phase by phase. We want to keep this session, of course, interactive. So, of course, you would get we will reserve a time for question and answers. But the propagation is not to teach or tell about the technology, but moreover about the nuances that we have seen so far while working for these 2 years around this and running the applications at scale in production, what it led to, and how really the platform approach helped us and what is coming ahead. So, of course, as you see, the lessons from building and deploying the multi-agent platform at scale. So this is what we are going to talk about. A brief walkthrough over the agenda. So outcomes that Elmos brought, then the learnings which are around at the code level or the developer level, what were those? And how really it bridged the gap between the business as well as the technical teams. Because when this all was shaping up, it was all a new thing, right? A new wave came with the ChatGPT launch. Everything changed the way we think. Today, it's I think, become common. Oh, I generated this code, that code. But it was not the case at that time. So how you prepare yourself for the time that is coming. So this is how we approach towards this. And then, from here on, where it seems to be heading towards, what is waiting for all of us to cherish, right? And question and answers. So let's spend some time on understanding why we even built such a platform, right? Because while working for the business at Deutsche Telekom, it was like on-ground reality was really complex. We were supposed to have a system that can be deployed for multiple countries, that can support multiple languages, and then at the same time, the same system should be pluggable into different channels altogether. Right? And the solutions which were available on that time, they were not actually, let's say, in a shape like they speak the language in which customer want. And also there are compliance, regulations at the local level. It was not there, like it could meet this. And there, of course, pluggability into various channels was not there. So we built the multi-agent platform, which is open source, open standard driven, and sovereign by design. So these were the 3 key principles. We carried it from there, and that helped us in shaping the Elmos, which is now incubated under Eclipse Foundation as Eclipse Elmos. Let's talk about the few wins that we saw in the Deutsche Telekom while working over there through the platform. So it was not only because its technology is shaping up and we want certain fancy architecture, or maybe because it's a time no one knows anything, let's do something. It has to be accountability factor as well included, what it is resulting into once the system is put into the production. Is it really helping the customers? So the information which is available over the public domain. So the business outcomes, we were able to process 4.5 million conversations per month with the system that we built. And of course, it was made live in 4 countries. And in fact, it got the bot, which was built on top of the platform, got Best Bot Award by CHIP in 2025. Let's compare it with the industry standards. There were already, at that time, the scripted dialogue bots, right? And how business generally measure the win. How the agent handovers are happening means how many times actually your bot or a system is able to assist, and or how many times it's failing and it's handed over to the human agent, right? And that's where when we compared the stats at that time in 2024, it was 38% fewer human handovers. That led to of course, the first agentic system in production, because it's the largest deployment of any such platform in Europe today. And then, of course, live since 2023. Let's talk, because we all are engineers, architects, let's talk about from the development angle as well, right? So, in order to convince the stakeholders or a business, you need to have certain parameters, like it's really working, right? And it all boils down to three things, right? Speed, scale, as well as the cost. So speed, when we measured over a period of time, which we are going to show you next after this, we were able to see like we reached to a level where the idea or the problem statement from the business with a pair of a data scientist as well as an engineer, we were able to ship the agent into the production. And then it comes all to the maintenance, quick iterations, how do we do that? And that's where the speed comes into picture with the cost savings, because it was not a big team that was built. And especially we were not looking for at a prematurely, okay, what's the skill set? Shall I hire some AI ML engineer? Shall I hire some data scientist? Shall I hire this and that? Because this is where most of the time also got wasted in 2023 or 2024. Because the technology was saying, oh, it's a Python framework, or the people in the enterprises mostly were around the JVM ecosystem, which is a Java. And how we bridge that, that's again become a part of the learning, which we are going to share. So scaling, we were able to scale it across 4 countries with the lean team, and of course with the same efficiency. So it's better now to look at how all these numbers were achieved when you just pull off the curtains and see what's in underneath.
Thank you, Jasbir. So first, the learnings. So back in 2023, when we started, there were many frameworks coming out of, we have heard like there was already some tending frameworks coming on GitHub, and then whether we should adopt this, whether we should adopt that. But the major challenge, like our previous speaker said, things were quite simple those days. But for us, the major challenge was how to get the speed of development, and how do we leverage our existing resources. Like, for example, we had JVM engineers, and they had the knowledge of the domain they were carrying along with creating different APIs, as well as the DevOps engineer who were helping us scale this system across multiple countries. So what we did is, first, we started with JVM engineers. We empowered them with a domain-specific language, ArcDSL, where they can just describe the agents, what is the name of the agent, which model it will be used, what is going to be the system prompt, and something like MCP came, but we had this tool registry where you can just mention the name of the tool, and it will get auto-registered with the model, and which model can use while working. So this gave, because it was JVM native, this gave the speed to the JVM developers. They felt at home, and they were able to ship the agents faster, also maintain the code for a longer run, and the quality remained high. And also, because of the familiarity, they were able to make tweaks here and there as soon as there was some requirement change or something. Then we had the speed. Then the next challenge was how to scale this system in production. That's where we came with this agent KTSYAML. It helped the DevOps engineer to manage the agent just like any other Kubernetes resource. So if you look at the resource, it's just another, the agent specification, the name, the description, and the tenants it will support. So now that it is a multi-tenant system, it has to be deployed in multiple countries. So you can define like this is the tenant information, this is where it will be deployed. But the next part was that a single agent, like for example, a billing agent, it can be accessed on web, on voice, on some other channel. And each of these agents, the behavior of those agents can vary, depends. For example, if it's on voice, then it has to be short and crispier. For the web, it can have like more rich visuals and all these things. So how do we do that? So the multi-tenancy was already baked in the system, and the capabilities. So capabilities was needed because it's a multi-agent system, and there is a single window, and you ask a question, and then when you ask a question, there are like 10 or 15 agents running, and at runtime, it has to choose which agent to route this query so that the AI agent can solve it. So we built a router on top of it, which leverages these capabilities and pass the user's query to the right agent so that that agent can solve. Then our third learning came. We had the speed, we had the scale, but the direction was still coming from the business teams. And the business teams were telling us, like for example, let's take an example before I dive in there, we have an agentic system and how the normal requirement flow will come. So for example, a business manager will give a high-level requirement to the product team. Product team will break it down into a specification, and the specification will come to the technical team, and then they will break down this task. And then the technical team will start iterating. Let's say version 1 came. So in this relay process, we see that there is a lot of business intent is lost. So after weeks, even months of iteration, we reach to a stage there is a version 1 of the product, and so business intent is lost. So we thought, now that it's a new technology, it empowers us with natural language descriptions and all. So we came up with ARC definition, agent definition language. And what ARC ADL is was, for example, if the business customer is coming up with a requirement, and what if that requirement itself become an agent's behavior? So we widely known as, in DT, it is widely known as use case prompting. So what we do is, in use case prompting, the business developer just write how the agent should behave. And we provide the whole infrastructure around it so that it can directly be converted into an agent, and then it can be retried, all the tools that were available. Like these days we talk about context engineering. So it should have all the tools and everything. So at that point of time, we provided all the tools as, like, for example, let's say there is a business customer or a private customer, and they both need to be handled by the billing team, so that it is available just as like a variable. So if it's a business customer, use this, or it's not, and then it will be orchestrated. And this helped us bridge the gap of these multiple meetings between business teams as well as the technical teams.
So thanks, Amant. So we have seen like how really incubation happens. We reach to a state, and then how it translated into an effort on ground. So we started with the development. So development, of course, with what we have as a talent pool with us. So of course, sticking closer to the JVM ecosystem. And this is the state of most of the enterprises today even, right? And of course, the other part was deploying it. How would you deploy? You cannot bring a new tool altogether and say, hey, now get trained, because it won't lead to you an immediate outcome. So then, in that case, how really it get closer to the skills that we already know, that's the Kubernetes resources. And of course, bridging the gap between the technical teams as well as the business teams. So this is the journey so far we have seen, and these are the learnings that we accumulated over these years, right? Now, as it all started to scale, and that's what before this talk also, we were talking about the complexity, which is increasing day by day, right? The DSLs, frameworks, platforms are not looking like a silver bullet. And there are reasons to it. If you see this picture, if this is an AI infrastructure, and I'll show how. So you will see, like, we are talking at this level, right? Agents, prompts, tools, and as the complexity increases, it starts to bloat. And we have same pattern repeated again and again and again and again in different scenarios. But it's a natural language system, right? And everyone has to do what? So there are conditions, there are rules, there are SOPs which require to be executed on top of those intelligence models. This was the initial thing, but as we see now, everyone is talking about agents, and every one of us uses the coding agents per se, right, today. Now, if you want someone to work on your behalf, it cannot be left without these three keywords. Mostly you will read them about every day, right? So which means there is a second level which is emerging. It's not only the top level that we have seen. There is another level which is emerging: observability, evaluation, guardrails, right? Now the interesting part is, if you see the market today, it's flooded with these products. Right? But when we So these products, I would say, individually looks brilliant, right? But when it comes to running a system in an AI infrastructure, then the question comes in, how I will make them to talk to each other? How really these will be glued together, right? And this is the major problem which have no answer. And it also brought in the vendor logins. In many cases, you ended up in locking yourself into a vendor, right? Although there are open source alternatives available, if you see, but still again the question arises how the top layer would talk to it. Then comes the interesting part. This is the state of the AI model integration, which starts to happen once you scale. Because it becomes a delicate integration, right? Anything goes wrong here and there. Any update happens into a model. It's all change on the top, right? And hence, the AI infrastructure is something that looks like, and it started bothering us. Like, how really from here the next phase would look like for the agentic computing. And it's not only the, I would say, application problem, it's underneath, and it has a lot more things to do. But before we share our view on this, we would not talk theoretically, right? Let's have a look at the demonstration, how really this could be solved if the way we have started thinking. So we would like to share with all of you today around it. But before that, let's get into the demonstration mode in a way. Think like we have picked the e-commerce journey. So everyone in the room uses e-commerce on daily basis, and there are typically 3 steps, right? We search for a product, we add that product into a cart, and then we do a checkout. Simple, very simple, right? And now everyone says, hey, I have got the model through which I can talk in natural language. Now the question comes, it's okay for a person who don't know what is underneath, but every developer, every technical engineer would start thinking, how would I make it work like this? Because this is true, right? How should I make it run like this? But now, before we go to the how part, let's see how these integration would have been done in a conventional system, right? And I think in this room, many of you would have done those orchestration for many enterprises or companies, and you know the amount of code it would require in order to orchestrate such a flow, where you would like to do this, right? You would like to add an underlined item, because this item is described beautifully in a natural language, into the cart, right? But before we do, or maybe Amant will show how we do it, or how, means it's not how, it's mostly an alternate way, the way we are saying. But before that, let's imagine all of you are trying certain frameworks in AI these days. I don't think anybody would not be, let's say, looking at this, because this is how it's becoming interesting. So just imagine if you are given such tools, either as MCP server or some API, you would like to write some tool that LLM can understand, and you have to write a code for it. Then what would happen? You also need to ensure like there is an observability built in, there is an evaluation to it, there is also a concerns like guardrails are well taken care. So it's a lot amount of code at least to be written in order to make it work, right? And this is how we have been taught so far till this point. And let's see how Amant is going to show it to us.
Thank you, Jasbir. So I'll quickly share. I hope it is visible. So first thing, I'll select a model. So Kimi K2 is quite viral these days because of its capabilities of tool calling, and often compared with GPT 4.1 in OpenWeight's model. So we'll first select the model. Then there is an MCP server of Allbirds where there are multiple tools available, searching the catalog, getting the catalog, updating it, and I'll be using this. I'll use the same prompt just we provided earlier. So if you look at the assistant, it is calling the API, and then it called the catalog, then updated the cart, and the item was added to the cart. Let me ask a follow-up question. So it is getting my cart and showing me what are my cart items. Now, while this happened in the front end, how it should look in the back end for us to observe what was there for us to monitor whether the tool response was correct and what happened at each step, whether these observability are there or not, right? And how we are approaching this kind of monitoring and observing the agent's behavior in a simple way that Jasbir is going to tell us. Yes.
Let's get back to the presentation.
Yeah, just a second.
Okay. So whatever you have seen so far is not an integration code written over weeks or days, right? It's moreover a one curl command. But if you see closely the structure, like it almost looks the same. You have an input, you have a system, you have tools, right? But right now we are not saying it's running in my memory. It's something API we are calling, right? Now if you see the another thing, it's an SDK code. So which is again, it's not asking you to write some observability code, plug in some this XYZ function here, do this logging, that logging, and it's actually written maybe in less than 15 lines of code, right? And because if documentation is a code, if natural language is going to be or code is going to be a natural language, then what should be the agents should look like? And that begins the next thing, ongoing learning, which the phase in which we are right now, or we are thinking about. But before I share how really this all we are thinking should go, maybe, I'm not sure whether we are right or wrong, but let's look at some past references, right? So when we started developing applications, right? So we always say, oh, I need one server, I need this resource, that resource, and then containers came. And we have a mental model saying, my code can run in a container compute. And then we also saw the cloud era, right? And in the cloud, we were saying, okay, it provides, if, for example, AWS, it provides you EC2 compute. You don't need to take care of any other things like wiring, networking, and everything comes out of the box. And applications or services or bigger clusters are even deployed directly on top of it. Then, shall we ask ourselves, like agents also deserve their dedicated compute, right? And the compute, which is natively built for agents, that should take care of observability, that should take care of the inference, model switch, that should take care of the agent lifecycle completely. I want to roll out one version, two version, roll back this. So this should be a part of a one unit, which we call as agentic compute. And hence we started chasing this idea. And we are let's say, in this journey right now, where we think like it's a time to build the agentic compute, and it has to be open at the core. It cannot be built alone. It cannot be built in silos. It requires a validation from different business, use cases, tough problems of the world, and hence we call it as AGC. And if this all resonates with the thought process that maybe all of you, some of you are carrying, so we would love to learn together. And thanks for your time. Thank you.
Thank you. Thank you, everyone.
And if any questions, we can take.
So I wanted to understand how you are building the knowledge base through which you're training your agent, and how you're evolving it basically, because like the example you just showed on searching the shoe, right? So when you give the black shoe, but how do you know which company or brand or those kind of things, and how are you actually adding that data and building it further?
Definitely. So it's not about building everything. So earlier we were thinking, I think 2 years back, when we were shown there is a vector database, you feed in something into English, it will do some magic, and once you start searching for it, it would do some semantic similarity. This is what we all were taught 2 years back. But then everyone realized when OpenAI released the function calling capability, like you can integrate your systems or maybe functions. And then another jump came in with the MCPs. And it's not going to stay here, then Google came up with A2A. Then, if you now closely see this idea, why MCP came? Because I do already have the system that I built over years. Even this allbirds.com, they might have built this website from 5 years, 10 years, we don't know. Which means they already know what customer search is and how really, because it's a business. The whole part is how agent would get a connectivity to this is. One way is the MCP tool. The another way is the A2A API integrations. There could be 10 more ways that would emerge. But the whole point here is, and that we should emphasize upon, how to leverage the existing components or the legal blocks that we already have so that it can be glued together. And that's what we are trying to do in AGC, so that that pattern that you have seen, everybody should not write every day, and it would start bloating about. I should focus on writing the lines of code which are relevant to me and my business, and not at like, okay, agent need this, so I should write it, because agent is not a burden, right? But so far we have been felt, okay, you need to learn something new because something is coming and you are not equipped to it. So that's what, let's say, means we don't agree to that even in the beginning. Like, why should I, first of all, learn XYZ skills in order to start using this technology? And hence, there is a fresh perspective, how really the things built over the years should not be thrown away. If it's a green field, there is a different approach altogether. But if it's an existing ecosystem, how we can start connecting, and there are few validations as well, because everybody talking about connecting world. If you see, the OpenAI ChatGPT now has Google Drive connectors. It has the MCP connector, right? And the reason being because this is the realization. You cannot do it alone. But we are firm believer of open source, and hence we started doing it within the public rather than doing something in silos.
Thank you.
Yes, we.
Hi, I may have missed some details because I was late and I am new to LLM, so don't mind my question.
No problem.
So I was asking that, are you building the model from scratch or are you fine-tuning the model from, because I saw the code, there was a Llama Maverick, you have mentioned the model.
Yeah, so model training is a one thing, which is a deep tech, right? Yeah. And many research labs are doing, and in the morning we have seen also, like within India, across geographies, there are this deep tech is being done. And the future is going to look like the fine-tuned, specialized small models. But how really you start building, because it's very, very low level.
Yes.
How really you equip a person who is very much habitual in writing the application by gluing this all together underway into as an infrastructure component. And that's where we are trying to see the things and as a big whole, which is not being thought through. And hence, it's also OpenAI says, like the models are getting intelligent, but their adoption and the real business value is still far away. Yes. And the reason is this hole in between, because it's not easy or directly nothing is available of such a kind who can actually give you that magical wand to do it all together.
Yes.
But so we are more into applied AI than the model development, and also we go with the philosophy that because back in 2023 and compared to this date, models are getting increased, in capabilities. So how we should keep things simple so that we can take things out, because as the model increases in its capabilities, as we go towards more determinism, how simple it is so that it is not glued to every part of your code base, so that it is hard to change the models and everything.
Yeah.
And I think time is over, but we are here around, so it's better we can have a chat. Yeah.
Yep.
Thank you.
Thank you, everyone.